All right, guys. So welcome to another problem in this series for linked list. This is problem 142, linked list cycle 2. Okay. So I'm assuming, and I hope that you guys have done linked list cycle 1, and you guys have some basic intuition, basic knowledge on problems that contain linked lists, okay, and how to solve those problems. So this problem reads: given the head of a linked list, return the node where the cycle begins. If there is no cycle, return null. Okay. I'm not going to read this paragraph here. This is the same thing that is done in linked list cycle 1. They give the same paragraph here. It just basically explains that that there's a cycle if, by following the next pointer in the list, if you keep going, that like you'll reach a position again. Okay, so like in this case, obviously the cycle is true here because you know that when we reach the end of the list, the next pointer of -4 points back to 2, and it goes back to 4 eventually, and it goes back. So we have like this closed loop, okay? And I did this in terms of showing you guys, explaining by like, these runners on a track, right? If you have a track that, it's just like a 400-meter loop, right? Despite of how fast the two runners or the three runners are running, despite their pace, they're going to eventually meet because it's a closed loop, right? If it's not a closed loop, then obviously the faster runner will reach the end first, okay? So taking that intuition and taking that knowledge that we learned from the first problem that I did in the series linked list cycle 1, let's go ahead and tackle this problem, okay? The follow-up for this problem is that we want to solve this using O of 1 space, right? We want to solve this in constant space. Okay, so using no additional memory, right? And we're going to do the same approach that we did previously, okay? So in linked list cycle 1, we said that we're going to have these two runners, okay? Assuming that this is the first example here, where we call them slow and fast, okay? Slow is going to move equal to slow dot next. It's going to move one position at a time, but fast is going to move twice as fast as slow, okay? Going to move fast dot next dot next, okay? So they both initially start here, okay? After the first iteration, what's going to happen? Slow will be here. Slow will be here, and fast will be here, okay? The third iteration, slow is here, and fast will be at 5, okay? The next iteration, slow moves one position, okay? So slow moves here. Let me re-put this up here just so it's better for readability. And fast moves twice. So if we follow this arrow, it moves once to 3, and then the second time would be there, okay? So following that, we see that there is a cycle here. Why? Because like I mentioned in the first problem, fast and slow are at the same position, okay? So that means that there must be a cycle because they meet, okay? This is known as our intersection, okay? This right here is called our intersection, right? Where they meet, okay? What we want to do is find the node where the cycle begins. In this case, we want to find this position, okay? Now, how do we do this when we have an intersection? Well, it's very simple, right? We can think of, after we find our intersection, right, which will be done in a different function, we then go to our main function that would check the node where the cycle begins. What we can do with this intersection is either grab S, right? We can grab S or F, right? Our slow or our fast pointer, return that, and then in our function that determines where the node where the cycle begins, we can then have another pointer, right? We're gonna have these two new pointers again, right? Our head, right, or our beginning of the cycle, or beginning of the list will be here, right? We'll call that pointer 1. Okay. What is pointer 2 going to be? Well, pointer 2 is going to be either slow or fast, depending on which one we return. And you're going to see that it doesn't matter which one we return, slow or fast, in that first intersection function. Okay? So then P2 would be here. Okay? This is P2. All we got to do now is move each pointer one position at a time. Okay? And you'll see why. If we move pointer 1 one spot after the first iteration, well, pointer 1 will be here, and pointer 2 will be here. Okay? On the third iteration, pointer 3 will be here. Okay? Pointer 2 will be here on the third iteration. Sorry, pointer 1. And where's pointer 2 going to be? Well, pointer 2 is going to follow, you know that it's here, right? What it's going to do is it's going to follow this arrow. It's going to end up in this same position. And notice, this right here is where the cycle begins. Okay? And this is going to be able to solve any problem that has a cycle. Okay. So let's go ahead and talk about the time complexity and space complexity. Time complexity, of course, is O of n, where what? Where n is equal to the size of the linked list, LL for short. Our space complexity, well, this is done in constant memory. Why? Because we only have additional memory for our slow and our fast. And we also only have additional memory for P1 and P2. Okay? Let's go ahead and solve this. Okay, this is, of course, assuming you guys have basic knowledge with the first problem. Okay? So we're going to create a new function, which we'll call it get the intersection. Okay? This is going to pass in as a parameter the head of the linked list, right? And this is going to return a node, right? This node that is going to return is going to be the quote-unquote intersection, okay? So, of course, we're going to go ahead and do our first check, right? If head is none, we return none. We have a slow and a fast that both start at head, okay? While what? While fast is true and its next pointer is true. Okay? While these two things are true, we're going to move slow one position at a time, and we're going to move fast twice as fast. Okay? When one of these conditions break, we know that there's a cycle in the linked list, right? This is the way to solve linked list cycle 1. While one of these break, fast or fast.next, there's a cycle, but instead of returning the Boolean value, we want to return the intersection, which could be either slow or fast, right? Because again, here, slow is here, okay, and fast is here. They're both in the same spot, so we can return either or. It does not matter. All right, in this case, let's just return fast. All right, so this function's done. Now, what I want to do now with this detect cycle function, right? The main function that the problem gave us is, let's get that intersection value, okay? So intersection, we know that it's this function and pass in the head. Why is that true? Because when we go to this function, pass in the head, we're here, it's going to come down here. This will detect that there's a cycle, right? And it's going to spit out fast. There's one thing here that I did not do is after updating these pointers, right? The crux of this is to check if slow is equal to fast. If slow equals fast, then we return fast. Okay, sorry about this little typo. At the end, we return none because when the loop breaks, sorry for the confusion, right? When the loop breaks, that means that there is no cycle, right? If fast.next points to none, there is no cycle, right? It's a linked list without a loop. We return none. But if fast.next is true and fast is true, and at some point slow and fast meet, then we know that there's a cycle and we're going to return fast. Okay, that's what this is going to do. Give us intersection. Okay, now we need to get 2 pointers, right? Well, first let's check something else. Let's do another base check here, right? Similar to what we did here, but instead of checking head, we're going to check if intersection is none. If intersection is none, we return none, right? If there is no intersection, we return none. Okay, cool. Now what's the next thing to do? Okay, well, the next thing to do is to get our 2 pointers. We know that pointer 1 will be equal to head. Pointer 2 will be equal to intersection. Cool. I don't know what the problem is here. That's weird. Okay. Good. Oh, I see. I spelled this wrong. Intersection. There we go. And I spelled this one wrong again. Okay. So P1 is head. P2 is intersection. How does this look in the drawing? Well, that's this, right? We said that in our drawing, right? P2 or our intersection, right, will be at the value. Let me erase these right here. Don't want to have too much on the screen. So we said that intersection is going to be what's here. Whatever is highlighted will be intersection, okay? Either the fast pointer or the slow pointer, doesn't matter. One of these is intersection, okay? And that's going to start at this position. So I'll just put an I here. And where does the first pointer start at? Well, we're going to say our first pointer is going to start at the head of the list. So that's going to start here. Intersection is going to be equal to P2. It's going to start here. All right. I hope that makes sense. So let's go ahead and move these pointers one at a time, because again, going back to the drawing, by moving the pointers one at a time, I'm just going to put P2 here, P1 here. By moving these two pointers one at a time, what's going to happen? P2 will then go here after the first iteration and P1 there. On the second iteration, right, P1 will go here and P2, of course, following this loop right here, will end up where? At the same spot as P1. So this is, as I mentioned earlier, the point of intersection. So let's go ahead and do that. While what? While P1 does not equal to P2. That's going to be this while loop, okay? All right, because if they do equal, then we know that we can break out of this loop and we return either or, okay? So while they don't equal, which initially they will not equal, P1 will be at the head and P2 is at that intersection that we found. P1 will equal to P1.next and P2 equals to P2.next. Good? When this loop breaks, what happens? P1 equals P2. Well, that's what we want, right? We want P1 to equal to P2 because that is the node that they intersect. So what we can do is just return P1, okay? We can similarly return P2, right? It doesn't matter which one we return because they're both going to be at that node, all right? And this is the end of the problem, right? Notice that this right here is, and I'll put this in a comment, linked list cycle 1, right? That's finding the intersection. And this right here is the main function that they gave us to detect cycle, and this is getting that node value. Okay, we run this. This is passes the test cases. Let's go ahead and submit this. Thank you guys for watching. Please be sure to like, comment, subscribe, share it to your friends. I hope this is informative for you. If you guys have any concerns or comments on the way I'm explaining these problems, please let me know via a comment so I can go ahead and try to fix that for you guys, okay? Thank you guys so much. Have a great day. Bye-bye.